Happy day, students. So in our last class we stopped over here in which we found that what is the force on this charge Q. Okay, and we had this minus Q here. So now what I am going to do is I am going to change this Q also in minus Q, and we are going to still find the force on charge placed at B. Okay, so how this minus Q is going to apply the force on this Q? Whether it's attraction force or repulsive force. We know that these are alike charges, so on this one it will be a repulsive force, or rather attraction force. So force will be like this. Okay, now because of this minus Q, again the force will be attracted, and along the line joining two charges, so force will be like this. And the third force will be because of this charge, and because of this charge the force on this charge is repulsive, it's like this. Okay, so if this force here between these two Q's, when the separation is A, if I say this is F, then I need to say this is also is F, because here also the magnitude of two charges is Q and the separation is A. What about this charge? What about this force here? Here is also the separation A or different? Here separation is root 2A. Okay, here separation and here separation was A, but here separation is root 2A. So what will be the force in this case? In this case the force we have to write F between, I should say, between B and D, it will be 1 by 4 pi epsilon naught Q square. I am writing Q square, I am not writing minus Q. Because of this minus Q already have taken the direction. So you don't have to write minus Q over here again. So Q square by root 2A whole square. What we are getting? It is Q square by 4 pi epsilon naught 2A square. And what is the force between them? Q square by A square. So this basically is half of F. So I can say that here force is F by 2. So these are the three forces which are acting on charge Q. So first we will find the force between these two. Now these two forces are at right angles, making right angle with each other. So what will be the resultant? Both are equal, so the resultant will be angle bisector. And how much this will be? When the two forces are equal and perpendicular, then this force also will be root 2F. Okay, now we will find this and this resultant. Now what is the angle between this and this? Again this angle is 90. So net force will be in this direction. How much? Again it will be root 2 times. Sorry, this is root 2F and this is F by 2, not root 2F. So we have to find this, okay? This is F by 2 and this is root 2F. So let's use the parallelogram law. F net root 2F whole square plus F by 2 whole square. Okay, into, because the angle is 90 over here, 2 into root 2F into F by 2 cos 90, that will become 0. So this will be the eventual answer. So this is 2F square, this is F square by 4. So we are getting here what? 9F square by 4. Okay, that is FB square. So what is FB then? FB is equal to 3F by 2. And F value? F value is the force between these two charges. So we can write F is 1 by 4 pi epsilon naught Q square by A square. So let's put it over here. This will be our answer for the question in which we are finding the force on charge B. Okay? Let's see the next question then. What changes we can bring into the same question. So this time I am going to keep a charge at the center of the square, and then we are trying to find the force on that. Okay? So let us see. In the first case, we are going to put the charges as Q on every corner. Here also Q, here also Q, here also Q, and here also Q. And here I am going to put the charge at the center. Okay, it's a square, and we want to find what is the force on this Q. What will be the force on this Q? 0? Yes, it will be 0 because this Q is going to apply repulsive force on this like this. This Q is going to apply repulsive force on this. This Q also will apply repulsive force, and this Q also will apply repulsive force. All are equal and opposite to each other. This separation between this capital Q and small q We can write that as a by root 2. Here also a by root 2. Here also a by root 2. Here also a by root 2. Okay, all the forces are equal and opposite, so their sum will be 0. Okay, so in this case we are going to get 0, no doubt about it. But if I am going to do this as negative, then what is the net force on this? Now that we have to find. What change will be there? The change will be this. The force between this Q and this minus Q will become attraction force now. It will be acting like this. Okay, this will be the force of attraction. Okay, so now force because of this Q and force because of this Q are still equal and opposite. No doubt about that. But the force due to this Q and this minus Q are in same direction. So they cannot cancel each other. They will be added. Okay, so if I say that this force is F and this force is also F, then the net force in this direction will become 2F. Okay, they are in same direction, so even if you use parallelogram law, the answer will come as 2F only. So let's write what is F then. F will be 1 by 4 pi epsilon naught Q. The separation is how much? A by root 2. So A by root 2 whole square. Okay, that will be the force because of all 4 charges on small q. What will be the direction? Direction will be like this, diagonally towards minus q in this particular case. Okay, more changes we can do. We can bring this as minus q as well. If this is also minus q, then what changes will be there? One change, that this force direction also will become like this. So in this direction also 2F and in this direction also 2F. Okay, F and F, 2F here, F and F, 2F here. This direction and this direction. So where will be resultant? Resultant will be in this direction. Okay, here 2F, here also 2F. And angle? Angle 90 because both are diagonals. So what will be this force then? Root 2 times 2F. How to find? We can use parallelogram law. The net force 2F whole square plus 2F whole square plus 2 into 2F into 2F into cos 90. Cos 90 again 0. So I am not writing that part. Here what's coming? 4F square plus 4F square. That is 8F square. That is equal to F net square. What is going to come here? F net equal to 2 root 2F. See, same thing I have written over here. 2 root 2F is the answer in this particular case. When we are going to take the square, or maybe you can take rectangles, the same way we are going to solve vectorially what is the force acting on any of the charges. Okay, let's move further. Going on to now another polygon, let's say hexagon's case is there. Now I think you understood that how to do it, all these questions that we have to use vectors to solve all these questions, okay? But now let's see the hexagon question. So hexagon is like this, a regular hexagon. Okay, and the first question is same that I asked in the case of square also. All the charges are here Q, Q, Q and Q. And suppose at the center I am going to keep another charge Q. The sides are A for this regular hexagon. What is the force on charge Q at the center? Answer is 0. No doubt about that. Okay, but suppose now I am going to change. I am going to remove this charge Q from here and I ask you that what is the force on the charge at the center? What is the force due to all the charges? What is the force on Q due to all charges? Okay. So tell me what is going to happen. One by one we have to see that how the forces are acting on small charge Q. So because of this capital Q first, what kind of force it is going to exert on this Q? Repulsive. This charge Q, repulsive. This charge Q, repulsive. This charge Q, repulsive. This charge Q also repulsive. Okay, if I say this charge is this force is F, then all these forces are actually what? F only. Because charges are same over here and the separation also is A. So this also will be A, this also is A, this also is A. Everything is A only in a regular hexagon. So this force and this force gone, this force and this force gone. Now what is remaining? This force. So net force will be in this direction. And what is its magnitude? Magnitude is 1 by 4 pi epsilon naught Q by A square. Okay, that's the answer in this case. Now let's put negative somewhere and see that what is the force coming. Okay, so I'm going to put negative, let's say at this point only here. Here we are going to keep one negative charge, negative Q. Okay, what's going to happen? All these forces we have already returned because of this charge Q repulsive, this charge Q repulsive, these are all repulsive. We have already done. Only minus Q I have to make. So minus Q is here. So what it will do? It will apply the attraction force. How much? F. What's going to happen? This and this gets cancelled, this and this gets cancelled, but this is in the same direction. So what will be the net force? 2F. What's the answer? 2 into 1 by 4 pi epsilon naught Q by A square. That's the answer. Okay, so I hope all these polygon questions you understood how to find whether charge is there or charge is not there or charge is on the vertex or in the middle, how to find. Okay, let's see the question entirely and try to solve it now. So let's say I am going to put the charges on this regular hexagon in a different way. Suppose the charge on this is 1 coulomb, this is 2 coulomb, this is 3 coulomb, this is 4 coulomb, this is 5 coulomb, and this is 6 coulomb. Okay, and at the center, okay, let it be Q, and the sides let it be A only. Okay, we want to find what is the net force on the charge at the center. Okay, so net force on the charge at the center. Now how to do that? This time charges are not equal on the vertex. All are different charges. Okay, so how to find? Alright, let's see what we can do. So the force due to 1 coulomb on Q, okay, will be in this direction. Okay, say like this. And force due to 4C is in this direction. Because both are positive charges, both are going to repel. 4C is going to repel along 1 coulomb, 1 coulomb is going to repel along 4 coulomb. So what is the net force in this direction? Shall I say the net force is because of 3 coulomb? Okay, let's see how can we say that. If suppose this is O and I say that this point is A and this point is B. Okay, so net force I want to find between A and B. What is it? So let's see the force due to 4 coulomb. So 1 by 4 pi epsilon naught 4 coulomb into Q by A square. It's in this direction. Now this is in opposite direction. So minus 1 by 4 pi epsilon naught 1Q by A square. Now what's going to come? Check. 1 by 4 pi epsilon naught 3Q by A square. That means charge due to, rather force due to 3 coulomb charge. What is the direction? This is the direction, towards A. So like this. Okay. Same way if you see here, this is 6 coulomb. 6 coulomb is going to repel it in this direction. 3 coulomb is going to repel it in this direction, but where will be the net force? Net force will be like this, and it will be because of what charge? 6p minus 3c. Again 3 coulomb. So this force also I will take like this. If I am saying this is force F, so this is also F. Third force you see, this is 5 coulomb, this is 2 coulomb. Again the difference of charge is 3 coulomb. This is also repulsive, this is also repulsive. So here also we can say there is force F. Only 3 forces are there? Yes or no? Right. So 3 forces. Now we have to find the resultant. This angle 60 degrees. This angle 60 degrees. So first thing is, what forces shall we add first? First I am going to get this force F and this force F, not this. Why? Because they are acting on the farthest side. and the resultant of this F and F will be the angle bisector of this. That means it will act along this direction. And if it is going to act along this direction, then I will add them directly to get the net force. So first these two, what is the angle between them? 120 degrees. Are these two equal forces? Yes. So what will be the resultant? Resultant will be F square plus F square plus 2 F into cos 120 square root. Cos 120 means minus 1 by 2. So this is 2F square plus 2F square into minus 1 by 2. This 2 gets cancelled. This is minus F square. So 2F square minus F square. That means F square. Square root of that is F. So that means these two are going to give the resultant as F, which is acting in this direction only. So this F and this F, total will be 2F. So final answer is 2F. But what is F? We already found. This is F. Okay. So 2F means 2 by 4 pi epsilon naught 3q by x square. That will be the answer. Okay. So these type of questions are there which you have to solve vectorially. One more question we will do, but it is slightly different type. Let's see how to do that. Okay, so I am making one circle and I am making its 12 parts, just like a clock or a watch. Okay, so see them. There is a circle like this and its parts I am making 12 parts, just like a clock. And this is, you can say this is 12, so let's put as 12 over here. 12 coulomb, 1, 2, 1 coulomb, 2 coulomb, 3 coulomb, 4 coulomb, 5 coulomb, 6 coulomb, 7 coulombs here, 8 coulombs, 9 coulomb, 10 coulomb, 11. Okay, and here I am keeping a charge again Q. Okay, and the radius you can take as A. The radius is A only. We have to find net force on charge Q at the center. What to do? Same way like we did in the last question in the case of hexagon. Okay, so what we will do first, we will see, let's say we start from 9 coulomb. 9 coulombs force on the Q is in this direction, and 3 coulombs force exactly opposite. Resultant will be what? Force due to 6 coulomb. Which direction? That direction. So you take it like this. Let's say that is F for us. Same way 8 coulomb here, 2 coulomb here. So net force will be due to 6 coulomb charge direction that way. That's also F. Same you see 7 and 1. Okay, again net force due to 6 coulomb like this. That's also F. 12 and 6. So where will be the force? Downwards. Something like this. 11 and 5. Force will be like this. Again due to 6. These are all F. 10 and 4. Okay, so how many are there? 1, 2, 3, 4, 5, 6. What is the angle between each? Each angle is 30 degrees. Why? Because 360 is this. And how many parts we have done? 12. Each part is of what angle? 30 degrees. So 30, 30, 30 here also, 30 here also, and here also. Okay, now there are two methods in which we can do it. First we find the resultant of the two parts, and then we find the final resultant, or we do it vectorially, take IE component and take vertical component and solve. So we can solve whichever way is better for us. I will solve with the resultant method. If you see that first is this force, I say 1, 2, 3, 4, 5 and 6. So what I will do is, first I am going to add first and fifth. What is the angle between first and fifth? 120 degrees. This is the angle. Okay, this is F, this is F. So its resultant will be where? On the angle bisector, that means here. Okay, so F and F when you are adding, and the angle between them is 120 degrees, result will come as F only. We did it in the previous case. So For that also F you add over here. So this we solved. This is over. This is over. Now this force and this force, the angle between them is 60 degrees. Again, the resultant between will be along the angle bisector. But the angle this time is 60 degrees. For 60 degrees, what used to come as resultant force? We will find it. F square plus F square plus 2F into cos 60. Now cos 60 and 2 gets cancelled. F square plus F square plus F square. 3F square. That means resultant will come root 3F. So because of this and this also you cancel. Result is coming root 3F. So along this direction, how many forces are acting? F plus root 3F along x-axis. Okay. So net force, if I am going to write it, I'll say 2F plus root 3F I cap. Now which force is remaining now? This force. Now you can say minus F J cap. This is the total force. What more we can do? We can find what is this F value. What is this F? So this is the force due to 6 coulomb charge. Okay. So F will be 1 by 4 pi epsilon naught 6 coulomb into Q by, what is the separation between them? A square. So this is F value and this is the resultant force. Okay. Further we can do, because there is 90 degree angle, we can solve it further or we can leave it over here depending on how the question is asked from us. Okay. So this way we can utilize this electrostatic force and we calculate the net force through vectors. Okay. In the next class we are going to use mechanics to calculate it. Okay.